let's dive right into this explainer because today we are going to completely flip how we think about the built environment. For decades, the construction industry has relied heavily on this really linear model: take from nature, make a building, and eventually waste the materials by demolishing it. But what if we treated our own cities as the next great resource frontier? We're going to look at a brilliant strategy for optimizing what we build. It's a concept that literally turns the concrete jungles around us into highly valuable material banks.
I absolutely love this quote because it totally shatters that old take, make, waste mindset. It introduces this thrilling reality that the finite resources we actually need for future construction are already locked into the buildings you see every single day. I mean, we are surrounded by refined materials. To build the future, we kind of just need to harvest the past.
So what does this actually mean? It means we are basically modern-day miners. Urban mining is this incredible approach of extracting steel beams, glass, wood, and concrete directly from existing urban areas rather than tearing up natural landscapes for virgin resources. And by recovering these materials to reuse them in new projects or even sell them on the secondary market, we aren't just saving the raw materials themselves, we're actually preserving the massive amounts of energy that originally went into manufacturing them in the first place.
Now, to actually pull this off, our little urban treasure hunt requires two really fundamental steps. First, we have to explore to find these hidden materials locked inside local buildings. And second, we have to evaluate if extracting and transporting them actually makes sense. It sounds pretty simple on the surface, right? But as you'll see, there is this super intricate balance of economics and environmental science at play here.
Okay, let's kick things off with step 1, explore, and see how we actually find the materials.
Because before we can mine a city, we need specialized tools to map out exactly where our urban treasure is buried and, what kind of treasure it even is. So we use an analytical tool called material flow analysis, or MFA. Honestly, think of MFA as this glowing, high-tech radar system. It systematically locates stockpiles of copper, steel, and wood that are just hiding in plain sight across our cities. Since the secondary market for building components isn't highly developed yet, using an analytical tool like this is absolutely critical for pinpointing the exact materials we need.
And this analysis is vital on so many levels. Not only does it map out the dynamic, ever-changing stock of materials sitting in residential and commercial buildings, but it carefully quantifies them. MFA literally tells us exactly how much steel or glass is sitting on a specific city block, and it evaluates the potential for direct reuse versus just recycling it. Plus, this data is a total game changer for governments. By understanding exactly what resources are locked in their cities, policymakers can make really highly informed decisions about tax incentives and subsidies to actually encourage developers to use these secondary materials instead of just buying brand new ones.
Which brings us right to step 2, evaluate, where we assess the feasibility.
Because finding the materials is really only half the battle. Now we have to figure out if we should actually dig them up. Here is where the core tension lies. Extracting secondary materials from a building takes skilled labor, it takes time, and it takes really careful deconstruction. So, urban mining only succeeds if the economic costs of extracting, assessing, and preparing that treasure don't completely outweigh the environmental benefits of saving virgin resources. It's a super delicate balancing act between saving the planet and keeping a project financially viable.
And the biggest catch in this entire process is what we call the transportation trap. Imagine this. You find perfectly good reclaimed steel beams, but they are located hundreds of miles away from your construction site. Shipping those incredibly heavy materials over massive distances burns so much fuel and creates so much carbon emission that you completely cancel out the environmental savings of reusing them in the first place. No way around it. Plus, all those trucking costs just eat away at whatever financial savings you had.
This exact tension is illustrated perfectly right here by comparing two crucial boundaries. Check out the blue ring. That represents the economic boundary. Basically, the maximum distance we can transport materials while still staying economically profitable. Then, notice the dotted green ring. That's the environmental boundary, the distance limit where the environmental benefits of reusing the material still actually outweigh the carbon emissions of transporting it. Understanding how these two rings overlap is literally the secret to successful urban mining.
So, let's break down the 3 possible scenarios you might face on site. In case 1, you face the economic pull. Here, the blue economic boundary is huge, stretching all the way to cross-border sourcing. This means it's financially profitable to ship salvaged materials from very far away. However, look at the environmental boundary. It's much smaller, restricted to just regional sourcing. If a developer chases the money and transports materials across borders here, they entirely destroy the environmental benefits. Those carbon savings only exist if we stay within that smaller regional green boundary.
Now, in case 2, the situation is completely flipped. The green environmental boundary stretches out much further than the blue economic one. This means there are massive environmental benefits to be gained even if you ship the materials from far away, maybe because the material is just highly carbon intensive to create from scratch. But the economic boundary is tight. It only makes financial sense if you source locally. So in this scenario, it is entirely up to the client or developer to step up and provide extra funding to cover the high transport costs if they want to capture those maximum carbon savings.
And finally, case 3. This is the absolute ideal scenario. Notice how the green environmental boundary and the blue economic boundary perfectly coincide around regional sourcing. In this amazing sweet spot, the financial profits and the environmental savings perfectly align. While it's incredibly rare to find out in the real world, when it does happen, it allows project teams to set an exact, mathematically precise, guilt-free transportation distance that maximizes both profit and planetary health.
So, what's the crucial takeaway across all these scenarios? Local sourcing is overwhelmingly your best bet. Grabbing doors, windows, and sanitary wares from a building being carefully deconstructed right down the street is the absolute safest way to guarantee both economic and environmental victory. By minimizing the distance between the mine and your new construction site, you slash transport emissions and logistics costs simultaneously. It's a win-win.
And to see how this works when it's successfully put into practice, we don't even have to look far. Just look at the municipality of The Hague in the Netherlands. They recently awarded a 10-year circular flooring contract where a staggering 80% of the flooring used is actually reclaimed waste. By treating their existing building stock as a quarry, they are actively urban mining 72,000 square meters of waste flooring and installing it directly into their official town halls and district offices. I mean, that is a massive, real-world example of government procurement driving the circular economy.
The transition to a circular building environment isn't just some theoretical concept anymore. It's a tangible reality happening right now. So as we wrap up this explainer, I challenge you to change your perspective. Next time you walk down your street, will you see just buildings? Or will you see the untapped quarries of the future, locked inside the walls of your own neighborhood, just waiting to be mined?